Looks like we have pretty good turnout for today. That's good. How did you guys like A2 and A3? Just out of curiosity. I'm getting a couple of thumbs up here, people saying it's okay. But you guys are all here, so I'm guessing you want to figure out how you can debug your code better. Are some of you wondering, why do you have all these gigantic lines of output when you make one small change and then your code doesn't compile anymore? Or something like that. There are all these little issues that come up with C++. I think the biggest thing to remember is that you need to make sure you can compile and run your code at any given time. And you need to make sure you're coding incrementally. And you need to be careful about all these different things when you're coding. So with that in mind, the way we're going to run things today is I'm actually going to write a small piece of code from scratch. And we'll debug it as we go along. And we'll also debug some issues that we run into when we run the code. So let's get started. I'm just in my home directory right now. I'm on my account. I'm just making a new directory so that we can write a couple of files. The example that I have in mind is a very basic task management system. What that means is, let's say you're working on a project as part of a team, or maybe you're working on a couple of different projects as part of a team. Then each project is probably going to have a couple of different tasks that need to get done. And maybe there's some overlap between them. In that case, one task might be part of a couple of different projects. So I'm going to create a system that allows you to simulate that. This is based on a real-world example, actually. I interned at a company called Asana last summer, and this is actually exactly what they do. So let's get started. We have no files right now. I'll just create some main.cpp to get started. And all of you can feel free to follow along if you have a laptop. Let's see. Yeah, we'll say we want to include IO stream. Then we won't have to worry about that, just so we can print stuff out as we debug. Okay. I'm going to start with this really basic program. Even though this is really simple, I still want to make sure this compiles. Okay, no issues yet. Let's see, what are we going to want to do? You can start out by printing a very simple error message inside main. I'm going to be using cerr instead of cout. In general, when you're debugging and you want to print stuff, it's better to write to cerr. Then you can search for all these calls later and then delete them. Let's see. So if we have some projects and we have some tasks, how would we represent those? Let's just say a task looks like this. It takes in a string saying the name of the task. So let's say I'm working on a task right now, run debugging session. And let's say each task knows who it's assigned to, and we can have multiple people on the team. So that's the name of the assignee, the person who's working on that task. The other thing we want is we want projects. A task can be part of a project, and a project can have multiple tasks. Let's say the name of our project is CS368. And yeah, for now, I think that's all we really need for projects. Just a name. So let's create these two classes now. So for the task class, let's say how to include an IO stream. This is task.hpp. And we have our class. Let's figure out what the interface looks like. We want the bare minimum so that those two little lines of code that I added to main.cpp will compile. We need a constructor. We already decided that it takes two arguments. It takes in the name, and it takes in the person it's assigned to. We'll just call the assignee. Okay, that's the bare minimum we need for now. Well, we need the CPP file too, actually. So then the CPP file looks like this. We'll say the task currently has no body, or the constructor has no body. Fill this in. Very similarly for projects. We have just the constructor, and it takes in the name. And let's create the CPP file for that. We have to include the HPP file. Project to do fill this in. Yeah, very simple code right now. Let's try compiling. Let's see, we have more files this time. CPP, sorry, task.cpp. So we wanted to compile, and well, we have errors. But the thing is, since we have so little code to start out with, we can actually look at these errors and fix them without too much trouble. What I'm saying is the compiler gave us very little output. This is one of the most important things about debugging. You want to go so incrementally that you can actually read the stuff. Task was not declared in this scope. We're looking at the very first area here. It's useful to go to the very top and then start working your way down. Task was not declared in this scope in main.cpp line 7. So something's wrong in that file, probably. Let's see what happens. Okay. It said at this line, task was not declared in this scope. Does anyone see what the problem is?
Have you included
Okay, great. Yeah, we need to say how to include the HPP file. And might as well do the same for project. Okay. So that should fix at least that problem. I'm going to compile again, and maybe some of these other errors might go away too. If not, then we'll fix those too. Okay, there's some error. There are a couple of errors actually. The first one says project.cpp expected unqualified ID before the closing paren token. Let's look at the file and see what happened. Okay, I mean there's not much here, but does anyone see the problem? Sure.
You didn't include the string parameter.
What's that? Okay, yeah, that's one thing. Okay. Well, there is still one more problem actually, which I can see right now.
We didn't say class before project.
We only need to say that in the CPP file. I'm sorry, in the HPP file. So I can just open that up right now. I'll just split that. I'll split this window in two. On the left-hand side should be, yeah, on the left-hand side is the HPP file. We said class project over here, so this is fine. Yeah,
I need to use namespace STD.
that's here.
Or on the,
There's no need. There's no need to duplicate that. I don't think that's the problem.
So that's actually a good thing. So why don't we need to have even the namespace std there, in the sense on the CPP file? Because even though we are using string there, yeah.
because you never use, because you would use the namespace STD in your header.
Mm-hmm.
So that the header includes the using namespace STD.
Yeah, that's a very good thing. So the hash include project.hpp, just what it does is just copies this HPP file and just pastes it there. That's it. Nothing else, nothing fancy happens. Okay. And that is also the reason why we don't even include any HPP file while we are compiling. Even while we are compiling, we only give the CPP files because the HPP files are just copy and pasted on the CPP files, on top of the CPP files. Okay.
Okay, so I'll just tell you guys the answer. Everything that you said was definitely, like, I can understand why you would do that. I can understand why you might think, oh, let's put it using namespace STD inside here and see what happens. And yeah, you could try all of those, but I know what the problem is. You need to say project : to indicate in the project class, this thing right here, we have a method called project that returns nothing, which is just a fancy way of saying nested structure. Yeah. So if you weren't sure what the problem was, you could try all of these different approaches and then see which one eventually ended up working. Yeah, but that is the problem. And same thing is going on in task.cpp. Yeah, I forgot the arguments here. So string name, string assignee, and let's say it's part of the task class. So C++ knows that those are all connected. There's no implementation right now. That's really important. We're not doing anything at all. We just want it to compile. Okay, those are all saved. Let's try compiling again. Maybe it'll work. Okay, maybe not. Okay, it's complaining about task.hpp right now.
You need STD there.
Yeah, that's true. Okay. Okay, let's see if we're ready this time. Okay, compiled. And just to make sure we're not doing anything horrendously wrong, let's just try running it. Okay, I added that error message inside of main. And it didn't give us a seg fault or an exception or a board for any other reason, so I think we're good so far. Let's try adding some more functionality. Let's start with task. Okay, we want the methods in this class. The very first thing we can do is just add a couple of getters. Wait, no, we don't want to wait. Okay. So a getter would return a string. We can call it getName. There should be a getter to get the assignee, which also returns a string. Alright. That's task.hpp. We'll fill in the corresponding implementations here. Again, we're not doing anything clever, we just wanted to compile. String task : get name. That's the first one. We'll fill this in a little bit later. The method returns a string, so we still have to do something here. So the compiler doesn't complain. We just return an empty string. This is what we were getting at in assignment 3. We wanted to just stub out all of these methods first with something like this. Some really dumb implementation that would at least allow the code to compile without even having the correct functionality. Return that. As far as I'm concerned, this should work. We will do the same thing for project.hpp. We'll have for now it's one getter method. We have only get name for a project. So for example, in our main.cpp, we said we have a project called CS368. So eventually when this is complete, we'll return that name. Okay, that's it for now. Get name. To fill this in. We return a dummy string. Okay. That's the only method we have for now. Okay, I'm not even calling these yet, but let's see what happens if we compile. It compiles. Let's see what happens if we run. Same output. This is what our code in main.cpp looks like right now. We're constructing these objects, but we're not really doing anything with them. So we can start by calling the getter methods. For example, my task.get name, or my task.get assignee, or for the project, you can call my project.get name. I think this will compile, but when you run it, since we're just using empty strings right now, we're just returning empty strings from each of those three methods, we're going to get nothing. We're going to get 3 blank lines. So yeah, let's fix that. So at this point, we've reached a point where we can actually start implementing the methods. Everything is good so far, just the overall structure of the code is good. So let's start filling stuff in. Well, first we're going to need to store some of these values inside instance variables. We'll call them string name and string assignee for the task. And those are private. Now over here inside the constructor, we can try setting those instance variables. And we'll get back to the getter method in a second. Private, inside the project, we only have the name. That's the only thing that matters. And inside the CPP file, let's just say this.name equals the argument. This is obviously only part of what we want, but I still want to compile. It's a good thing we did that because I made mistakes. Let's see, we'll start with the first message. What happened here? Request for remembered name in this. Something, something, and then it gives us a suggestion. So, it actually, in this case, the compiler is pretty helpful. It's actually telling us what's wrong. It says maybe you meant to use arrow. And it tells us where the problem is. It's right after this dot, which means the dot is wrong. Same thing over here. A lot of people have this issue during office hours, so I thought I'd bring some attention to it right now. Okay. Hopefully that's it. Okay, again, we reached a point where we can compile, but we haven't reached a point yet where we can get the correct outputs that we wanted. But that should be a pretty easy fix right now. return the stuff that we created earlier. And very similarly inside project.cpp. Okay. Can we compile? Yes, we can. Can we get the correct output now? Is this what we printed out inside main.cpp? I think it is. Yeah, we have an error message inside main. We have a message with the name of the current task that I decided to create, the assignee of the task, which is me, and the name of the project. Does it all make sense so far? Like, I haven't done anything overwhelmingly complicated yet, although I will pretty soon. Okay, so tasks and projects exist pretty separately right now. But obviously, we want a project to contain its tasks. Like, we want a project to know which tasks are associated with it. We also want each task to know which project it's associated with. This is a many-to-many relationship here. So then, each of these is going to, wrong file. Eventually, each of these is going to have some kind of vector representation of all the stuff that's inside it. I'm just using a vector for simplicity. Like, you could use an unordered set or some other type, but we'll just go with the vector for now. So let's add that inside here as the next private variable inside the task. So a vector of some type, we'll come back to that. Projects. Something we have to do even before this is we have to make sure project is visible inside here. Which means we need several things. We need vector, it's one thing. And we need to make sure project is accessible inside the task class. Inside project.hpp right now, very similarly, we'll have a vector of tasks, and we'll have the corresponding include statements. Make sure a vector exists, and we'll make sure a task exists. So yeah, this is going to be interesting. Let's see what happens when we run this. Yeah, there's a problem. do any of you know what the problem is?
Like copying and pasting the header files.
Yeah, I'm glad we mentioned that earlier. But yeah, we're trying to copy one header file into another. Then we're trying to copy that second header file back into the first file. So the compiler is getting into an infinite loop. This is one of the few situations where that can actually happen. There's a way to fix this. I just happen to know this off the top of my head. You just have to say class project in the task class. This is the forward declaration of the class. Kind of similar to what we did for methods, except now we're doing a forward declaration for each class. We can do the same thing inside project.hpp. We can have a forward declaration of the task class. Okay, let's see what happens this time. Okay, that did not work.
Forgot to get rid of the includes.
Mm-hmm.
I think the includes still need to be there. Actually, well, no, maybe not. If we have them. Yeah, we have a forward declaration. Actually, yeah, so that's probably necessary. Let's see. And what the problem is. I think this is necessary in both of these cases. I did forget something though. Do you guys see what I forgot? It's still kind of related to including the file that includes the original file and kind of getting into the loop.
So now, do you guys understand what is the problem here? Anyone? Can someone explain? So don't worry about the forward declaration or anything like that. But what is that loop that is happening here? Do you guys understand that? So here, okay, let's assume this file, okay, project.hpp includes task.hpp, okay? And Varun, can you like split the screen and open task.hpp?
Okay.
And in task.hpp, before he commented that out, in task.hpp we are also including project.hpp. So it says this needs this file, but that file again needs this file. So it's in a loop. So it just tries to include each other like in a loop. So the compiler gets confused what to do here. And yeah, do you guys remember like how can we fix this?
Is that if not defined statement?
Yep. So do you remember we did not explain this in class, but we had like in the assignments something called include guards. So all the header files will usually have like include guards. If that header file is already included, it will just skip including that header file.
Yeah. So we'll just add those here. Define task underscore HTTP needs to end at the bottom. And if this file is hopefully done, let's do the same thing over here. And project HTTP define project HTTP. And then end that. I'll save and quit out of both of these files. Okay, and now we're good again.
So do you guys know what hash if ndef means? What does it stand for? Anyone? So if ndef just means if not defined. So can you open that file Arun again? So we are actually defining a symbol here called project underscore HPP, just like a variable. It's a symbol here, but it's a symbol for the preprocessor. Preprocessor is a component in the like compiler, inside the compiler, like the entire compiler, which does this job of like including header files and everything. So for the preprocessor, this is just a symbol. So when you include this file for the first time, okay, that project underscore HPP, that variable or that symbol will not be defined. So it's saying if it is not defined, then define that symbol. It just means, which just means like create that symbol and then do all these things and end that if condition, whatever you started there. So the same file, when it is defined one more time, the first condition itself would fail. If not defined, project.hpp would fail because it is already defined. And so it will come to the bottom of the thing. That whole thing till endif will be just ignored. Does it make sense? This is what happens with that. This is what happens in the include guard. This is called the include guard. We are guarding the includes. Yeah.
Okay. Since we added a vector inside each of these, we might as well have a getter method too. And then we'll add something a little bit later that allows us to actually add to this vector. So we're going to add two methods soon enough. The first one is just a getter. Get projects. Okay. Wait, did we put that type as? Vector of project. All right. And the implementation now. Vector of string task, colon, get projects. And we just return that instance variable. Same thing for project now. Vector of task, get tasks. And yeah, for each project we get tasks. Now the project dot cpp will have get tasks method. Okay, my compiler is up here. Here's the command again. And let's try it. Okay, I think we kind of saw these errors already. Here's one. Okay, what is this next one? It's like task.cpp at line 16. There's something that doesn't match. And there's a related error here. It's like task.hpp line 17. It says we have a method get projects that returns a vector of project. Okay, looks like I just made a typo here. So the return type is wrong. We really want this to be a vector of project. Okay.
Now, Arun, can you just pause here? So, with this error message, okay, whatever we are seeing on the screen right now, what did he just take away from that? So, did he read the entire error message while debugging it? So, for example, if when we are like reading these error messages, we need not worry about like understanding entire things. So, for example, if I start reading, okay, error prototype for vector of basic std basic string of char some task get projects does not match any in class task. Okay, so the idea here is like even though there are so many details out there, okay, we need not worry about all the details. First, this is a small error message. Okay, just looking at the error message, what I would look at is just those two lines where they have that caret sign, the caret symbol, that like up arrow kind of. So I just see there they say like, okay, in task get projects there is some error, and they also show something bottom and in the like in the second error message in get projects. I just look at the, I'm just trying to tell you guys like what I look at when error messages are coming so that it may help you. So just look at those two things and see, oh okay, right, I can see that right away that this is a vector of project but this is a vector of string. And that is the first thing that I look at. And one more thing is like if there is error message of like 1000 lines, okay, don't get overwhelmed. The only thing that you should be worried about is the first error message. That's it. The only thing that you should be worried about is the first error message. But if that does not make sense, maybe look at the second one. Try to fix the second one, okay? Something like that. So it is like even though there are like 100 error messages out there, we are not going to fix all the 100 in one go. Do you understand that? And you fix one, it will remove actually 90 other error messages. There will be only 10 more. So the trick is only concentrate on the first error message and then proceed.
Yeah, and that's actually why I've been saying let's look at the first error, the very first. Because what tends to happen in C++, if you have a lot of errors, is if you fix the first one, then you fix a bunch of the ones after it too. And that's why I keep saying set start at the top. Okay. So let's actually call this getter method and see if it's working correctly. Well, it isn't actually. It's like we keep returning an empty vector, but we can at least do something with that vector. So let's say we have a vector of tasks that we get. And we'll get that from the project. We can also have a vector of project that we get from the task that we created. Get projects. Since we're dealing with vectors again, we don't want to make the same mistake as before. I think I made this error at one point. But yeah, we had to have an include vector. I added approximately 3 lines of code. Let's compile. Okay, even with 3 lines of code.
So what's the problem? Did you even find out with this error messages?
Tasks isn't a vector of tasks. It should be a vector of tasks.
Yeah.
Yeah, just a typo,
So
yeah.
many spelling errors today. Vector of task, that's the name of the class. Okay, we compile it. Do we crash? No, we don't. That's good. But we're not actually doing anything useful here. What we want to do is we want to be able to add stuff to each. We want to add tasks to a project. We want to add projects to a task. And then we want to make sure if we can call get tasks and actually see the correct output. So I'll take this moment to introduce a new concept in C++ that you can use for debugging. Right now what I've been doing is I've been checking the error output, all these print messages. Like I print this thing, I print so and so and so things, which have been correct so far. But rather than looking at each output individually, it might be easier if I do something in the program that says, check if, let's say, myTask.getName returns exactly what I'm expecting. If it's not, then crash at runtime. There's a way to do that in C++, and in most modern programming languages. And that's using something called an assert statement. I'd like to make a disclaimer right now. It's good to use asserts in your code for debugging, but please remove them before you submit a project. Because if you have an assertion in your code and it fails, then you're going to fail that particular test case that I use in the automator. So yeah, asserts are good for debugging, but please comment them out or delete them. That's even better when you're done. Okay, we want to assert a couple of different things. Right now, each of these should be of size 0. I think it's called size. We assert this thing to be true. Very similarly here. And let's see if the program crashes or not. Are we going to crash? Well, we should compile. That's good. Are we going to crash? Okay, we didn't crash. We reached the end of the output, and it didn't have any kind of error message at the end. So let's do a couple things now. We'll add some methods to modify each of these objects. And then we'll assert that if we add a task to a project, that we get the desired behavior. So inside a task, what we're going to do is we're going to have a method called add to project. We already dealt with the circular dependencies problem, so this should be okay. Here is our stub for compiling purposes. Inside a project, we need some way to say, okay, now let's add a task to this project. And then we'll add the corresponding implementation. Here's the argument, sorry. Add task given the argument. And for the CPP file, here comes a stub implementation. Void project : add task, which we will fill in. I forgot the parameter. Okay. There we go. Up inside my history is this to compile. Can we still run? Yeah. I'm going back inside main.cpp. What I'm going to do right now is I'm going to add the assert statements first. As in, I'll call these methods. So my project dot add task, my task And we'll assume that when we add a task to the project, the task, the task is part of the project. And we'll assume that the task is made aware which project it is in. Does that make sense? Instead of having to call both of those methods that we just defined, we should only have to call myProject.addTask. And that should update both the project and the task. They're in state as appropriate. But when we do this, and then we call myProject.getTasks, and project equals myProject. And task will get projects. Each of these should have size 1 right now. The project has a task, the task has a project, and each of those numbers is 1. I'm writing these test cases first. And then we'll write the code so that it actually passes these 2 assertions that I added. If we compile, and then we try running it, this is the kind of error message we get if an assertion fails. Yeah, the program just crashes at that point. The very first one failed because we don't actually have anything inside this method. But let's add that. So when we're in the task class that we're adding to a project, this one is relatively simple. This one does just one thing, which is it says inside this projects vector, we call pushback the argument. On the other hand, this is going to do 2 things. This is going to say we're doing this. We're updating the internal vector just like we did inside the task class. But we're also updating the task. Add to object. And we're going to have to add it to this project. Let's see how this runs now. Hopefully, if we can compile, then we'll get the desired behavior. Okay, well, there's some error here. Let's start at the top again. Project.cpp, line 17. No matching function for call to add to project. Why did this happen? It tells us, there's a little pointer here saying this argument seems to be wrong. Yeah.
Is it because that's the pointer and not the project itself?
Yeah, that's right. So we'll get to pointers a little bit later in the class. But just remember for now that when you're dealing with this, you have to be a little bit careful. Like so. Okay, I think we're nearly done here. I'd like to spend the last several minutes for this session on GDB, which is the debugging tool. So we'll try to finish this as quickly as possible. We compile, that's good. And we want to pass both assertions right now, each of those 2 that I added. And we also want to make sure we didn't break anything before, which I think is a little bit unlikely, but you never know. Okay, something still failed. It says main.cpp line 26. That assertion failed. Here is the assertion. So the first one passed, but the second one didn't. Yeah.
We never added a project to the task.
So when we call project.addTask, if you look inside project.cpp addTask, it should do both. It should do both of these things. So in the interest of time, I was kind of hoping to step through this code a little bit more closely, but I'll tell you right now, what I would have done in this case to figure out exactly what the problem is I would have added print statements inside here. I would have said something like, inside project add task. I would have said something like that. And then I would have said something similar inside the other method. And then I would have seen which statements are getting printed out. And then that would probably help us narrow things down a little bit. But I want to get to GDB, it's really important. So I'm not going to run through that entire example. Instead, I'll just tell you what the issue is. The issue is that we should be passing all of these arguments by reference. We should be doing that. Right now, when we're passing in the arguments, we're actually creating a copy of the original task. So when that happens, the sizes of the vectors get a little bit messed up. Because we're not, instead of updating the original task here at this particular line, we're updating a copy of the task.
So do you guys understand this? This is actually more than debugging. It's about like passing parameters. We are passing a copy of the task. Instead of that ampersand saying if you don't give it pass by reference, we are passing a copy of the task, and that project is just added to a copy which will die or which will be destructed immediately when that method ends, when that add task ends. And that's why that size was not updated. Yeah.
If you don't understand, that's okay. This one is pretty subtle. But we'll just make all of these changes right now. We changed tasks. We changed one of our CPP files. I'll put out a main. Inside project.hpp, you want to pass by reference. Inside task.hpp, we want to pass by reference. And then inside task.cpp, let's go down to the bottom. Here's the method. And now this one matches the HPP file. Let's quit the save and quit out of here. And here's the compiler. Okay, no error messages. All the assertions passed.
So can someone explain what an assert means? Yeah.
It's just, it sees if the statement that you pass to it is true. If it's true, then it does nothing. If it's false, it works program.
Yep, that's it. So assert just evaluates the thing that you go inside those parentheses, and it should be true. It's saying, like you are saying at this point in the program, I am pretty sure this should be the value of the project size or something like that. And if it is true, it just proceeds. If it is false, it will be like it will fail there. And usually these are very useful in debugging. For you to make sure, okay, I know this should be the case here. If it's not the case, then you should go back and look at that.
Yeah, and in fact, in the unit test that I released and also in the autograder, this is essentially what I'm doing. I'm using a slightly different function. I'm not calling this assert. I'm actually using something different that's provided by Google Test, but it's really the same idea. And speaking of the autograder, since we're done here, please comment these out. Don't submit code that has these assert statements. That's going to mess up my autograder. I'm going to be really mad. It's going to mess up my autograder in the sense that you'll get a 0 on that test, so I think you'll be mad too. So yeah, obviously it'll still run the same way. And yeah, I think we're good here. Let's use the last 10 to 15 minutes to look at GDB. GDB is a tool that you can use to debug when print statements and assertions and whatever else you can think of is no longer adequate. It's actually an extremely powerful tool. You can do a lot of really amazing stuff with GDB. You can like hack into existing binaries and find security holes and stuff, but I'll leave that for a different class. Yeah, so GDB is really awesome. And in this class, we're going to use it for debugging. If we want to run GDB, then we're going to have to say GDB followed by the name of the binary, which is the compile file. And it opens up this thing right here, a lot of different output, which I'm actually just going to ignore. There's one thing that I neglected to do here. If we try to use some of GDB's functionality to start stepping through our code one line at a time, let's say we want to start in main, we set a breakpoint in main, and then let's start running our code. Then it's working for the most part. Let's try the next line of code. We're seeing like all these weird errors, and then we exited. So something happened. We didn't actually do what we wanted to do. And the reason GDB didn't actually help us here is because when we compiled the file, we didn't specify a debugging object. -G means include stuff in a.out that will be helpful for GDB, so that when you actually want to step through your code line by line, then GDB can actually do it. It should compile exactly the same way, it should run exactly the same way, and now we can also debug with it. So I showed you a couple of very basic commands already, but I'll go through those again. Let's set a breakpoint. This means we start running the program, and whenever we reach this function, we're going to stop. We set the breakpoint, now we start running. All right, there's the breakpoint. And we reach this line of main, it's the first line. Something else you can do in GDB is you can say, let's list the lines of code inside a particular file or function. I think you can do this. No, you can't do that. It has to be a function. So this showed us, what we did right now is we just took a look at the first couple of lines inside main. As in the line int main, open brace, a few lines before that and a few lines after that. That's what the list command does in GDB. So which commands did we just use so far? We used break to set up a breakpoint. We used run to start running our code until that breakpoint. We used list to actually look at our lines of code. Now we can start stepping through our code one line at a time. If you want to go to the next line of code, right now we're at line 10, because that's the first line of main. Let's go to the next line. We'll execute that line and move to the next line by running the next command. Here we go. We executed the line of code. That's why we got this output over here. Like, this is not something GDB printed. This is something that we printed. And we moved to line 11, which is this thing. Create a task with these two elements. Let's try the next line. This is the second line of code. The line that gets printed here means this is the line that's about to be run, if we say next again, and so on. So we can try running this line. Again, we should expect to see some output. Yeah, there's the name of the task as expected. And I'm just stepping through several times. That's the next command. Let's say we want to step through each line of code. As in, instead of going to the next line in main.cpp, we want to go inside here, inside this line, into the getTasks function, and see what's happening inside there. So the command to do that is called step. This steps into a function. Here we go. We are at project.cpp line 12. Let's say we want to look at a line of code around project get tasks. Here we go. Lines 11 through 13 are the ones that we want. Inside there, we're just saying which are this error tasks, which we already know. That's going to be the next line. So let's execute the next line. We reach the end of the function, and we're back inside main now. So we finished line 17 of main, and we're about to do line 18. step through your code. Something else you can do in GDB, the real reason GDB is useful is because you can actually access all of the variables that are inside here, and you can see what their values are. So let's try printing stuff. We created at line 17 a vector called tasks. What would happen if we print that? We're going to get some sort of output. This is kind of helpful. It says tasks is a vector of length 0, capacity 0, which is it's empty. This is not defined yet, so we get a nice long error while was unexpected. Okay. If you want to see all the variables that exist in whatever function you are inside right now, you can say info locals. This is another command. The command name is info, and you're saying within info, I want to specifically look for the locals. How come not? Oh yeah, since projects hasn't been initialized yet, it's a little bit confused. Let's just do that. Okay, there we go. There's some useful output. These are all of the local variables that we defined inside our function main so far. We have my task, projects, my project, tasks, and projects. That sounds about right. If you want to see some other stuff, some of the other variables that are available, you might be wondering, okay, what about the parameters? Technically, parameters are not local variables, but we can get those too, those info args. In main.cpp, yeah, there are no arguments. And one more command that should be useful is info stack. What this does is it tells you what the current stack of the program looks like. These are just the functions that have been called so far. So right now we're inside main. Yeah, that's the only thing on the stack. So that's the only outcome we get.
So Arun, can we step inside some other function?
Yeah.
And then show the same thing?
Yeah, I kind of reached the end of main. There's not much left. So let's just say we'll run the rest of the program. All right, done.
So continue, just goes till the next breakpoint. Since we did not have any more breakpoints, the program will just terminate.
Yeah. And since GDB finished, we can actually run it all over again. We just say run. Our breakpoint inside main is still there. So we'll do everything in the program up till that point, which is nothing. And here's our breakpoint.
But now while we are running, does anyone know how can we even look at the code? So wouldn't it be very useful to look at the code and debug at the same time? I mean, visually look at the code as we look in Eclipse or something like that. Does anyone know how to do that in GDB? So there is an option called Control X. First you should press Control X and then A. Okay, Varun, can you try that? Control X and A.
Control X?
Yeah, Control X and then A. Yeah.
Whoa.
So your code just appears there, and whatever you do, you can just like now look at your code. Now if you press next, it visually shows you what is like where are you in the code. So for me personally, this particular feature in GDB is very useful because I visually want to see whatever is there while debugging. And most of the people prefer the other way also, just like using GDB as it is. But since I prefer this, I just thought of like letting you guys know. Yeah.
Yeah, I didn't know that actually. I just learned that today. Okay.
And then just to use the same previous command like next that we are doing right now, we can just press enter. Just pressing enter will just execute the previous command that we just typed in. If you want to just go next, 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 you need not type next, next, next. You can just type enter, enter, enter. And even if you have something like just the prefix is enough, just n is also enough for next. For all the commands, it's like that. Yeah.
Yeah, so if you type in n, GDB will know that that means next. Similarly, s will mean step. So then I'll just use those just to keep the output a little bit smaller. Let's step into line 11, the constructor of task. All right, wow. Yeah, some of the output sometimes is a little bit confusing. It just looks like, yeah, this is what happens when you're passing in strings and vectors and those kinds of things. So let's try some of the other commands. I mean, we're kind of running out of time. Let's do info stack. What does the stack look like? We have number 0, task constructor. And then number 1 is main. Let's try info locals. There's nothing right now. But we do have arguments or parameters. And this is what they look like. We have this, because we're inside a method in a class. And this is just the address, which is kind of expected because this is a pointer, which means it stores an address to something else. We have our name, and we have our assignee. I don't know why the assignee is empty. It's kind of strange. Okay, we can set through each of these lines. We can try printing stuff too. We can try printing the name. Yeah, there's the whole output again. Here's the assignment. I don't know why it's empty. Okay, there you go. That's not an initialized yet. We reached the end of the constructor. Okay, there's the correct output. Yeah, that was a little bit unexpected. Yeah, so you can use print statements like that. Just be careful if you see kind of an unexpected output, like all this weird octal or hexadecimal stuff. But in general, if you want to inspect all these variables in your code, if you want to see what what the stack trace looks like, if you want information about exactly what code path your code is executing, then this is what you can use. Okay, I think we're pretty much out of time. I'm just going to say continue, and we are done here. That's the end of the program. To exit from GDB, you can just say quit, or Q for short. So yeah, does that make sense? I think one last thing I'd like to say is, in general, when you're trying to debug, GDB is the very last thing that you want to use. In fact, if you're coding on your own computer, not in the lab machines, you have stuff like CLion. CLion has a debugger built in, I'm pretty sure. So you should use that first. I think using that kind of debugger is a lot easier than using a command line debugger.
So, but
you
even
basically do all the same operations. You can say next, step, continue, and so on. But there's like a nice graphical interface. You don't have to type these things in. Yeah, so that's debugging for you. That's print statements, assertions, coding incrementally, making sure your code compiles on a very, very frequent basis. And if all else fails, you can use a debugger.
if you have any questions, yeah.
I know you spoke about this before. We print C arrow when you were trying to find out the error in our code and we ran the tests on it. But in general, when do you use C out and C arrow?
Like C out versus C error?
Yeah, for debugging purposes.
In general, it doesn't really matter. If you're dealing with my tests, so at least for the last assignment, I was doing something a little bit strange with the code. Your code actually had to print to C out.
Right.
I'm sure all of you were aware of this. So what I did for all of the unit tests that I wrote is I actually took this stuff that was printed to C out and I did a little bit of magic in C++ to redirect it into a string. So essentially my tests swallowed anything written to C out. If we try printing to C out for debugging purposes, then you weren't going to see anything. My tests did not swallow the output to C error. If you wanted to print to C error, then you can use that for debugging. So in general, I say it's better to print to C error than C out.
So one thing that I have observed while working in production C++ code is C out and C error are two different things, mainly because if you want to extract out the error output, because when you're running a code base with 100 files in it or something like that, you want to just see the errors separately when compared to the normal output that's being printed. So you should think of these two things as two different files. The Unix operating system actually treats these things, the std out and the std error, as two files, just files, okay? And it means you are writing some output to like a file called std out, and you're writing output to another file called std error. And it would be so easy to just open up the things that are going to the error output separately, even though it is printed here, because by default std error is just redirected to the console output by default. But we can, while we are running our program, okay, ./a.out, we can, even there are some tricks to say, I want all the output to be printed, std, whatever is printed, std out to be printed on the console, but I want the error outputs to be printed to this file called error.txt. We can do that. So there is something like output redirection, and we can say, I just don't want to like that. The syntax is like two. There will be like two. There are three streams here: 0, 1, and 2. 0 stands for standard input, 1 stands for standard output, and 2 stands for standard error. And we can say I want to redirect the standard error to this errors.txt file, but I want to just see the normal output on the screen. And so that will be like really useful when you're working in really large databases, sorry, in large like code bases. And yeah, and that's why when you're working in companies, you should be very specific about, okay, this should be printed to the console, this should be printed to the error file, error. So this should be std error, this should be std out.
All right, thank you.
Cool.
Okay, any other questions? Okay, I think that's it. Thanks everyone.
Thank you.